I think I should be audible now. Thank you. So thanks Ram for that introduction. And I would say that although everyone believes that founding a startup is a dream, it's anything but. So I think I'll just leave it at that. I'm Abhimanyu. I'm the co-founder of a company called Koala Lab. Koala with the test tube, as you can see on the top there. We are building secure container technology, and my co-founder Abhishek will talk about that a little later. But what I'm here to talk about is not that. I want to talk about securing your CI/CD systems, and this talk will mostly be about why securing your CI system is important, the nuances of how to do it, and I also talk about eBPF, something that we've used to actually do that. So maybe just taking a little bit of a step back. You've been today hearing a lot of conversations or a lot of talks about security and securing open source. And for all of those who've been involved in the security space, you know that CI is the orchestration center of security orchestration center of the SDLC. So all your SAS scans, code scanning, secret scanning, that's where all of that happens. But what I would say is that CI has also become the new attack surface. So I'm guessing you've heard about SolarWinds, Code Cove, and I'll just mention that a little bit later. But the reality is that the industry has done a lot of good work on securing your production systems, on securing your cloud systems. But the infrastructure that we use to build our code, that also has become an attack surface. As we know that open source is a huge attack surface right now. But the supply chain attacks also happen through CI systems. And the last part I want to mention is why this is important is because CI itself has become quite complex. There has been a true shift left that has happened. Developers are now writing the integration code that goes into the CI. CI is a highly privileged environment in the SDLC. And not just that, but for all of you who know about GitHub Actions, Jenkins plugins, Circle CI ops, there is a lot of open source code also that is now being used in the CI itself. Hence, the security has become more paramount here. And given developers are writing some of this code to integrate their main code, and developers for all of you who might know, do not care about security that much. It's not something that's top of mind for them. So hence CI security has become even more imperative to focus upon. This is just a little bit of a chart that I had for the threat vectors in the whole SDLC. This is a GitHub version of it. I'll just focus on this a little bit. But if you look at the CI runtime or where the code gets integrated, there are two main attack vectors there. There is secret exfiltration and build tampering that can potentially happen. And SolarWinds was where a build tampering happened during, was an attack where build tampering happened and attackers were able to change the code which went into production. And CodeCo was one attack where secret exfiltration happened. So CI already has a lot of these secret environment secrets, which include GitHub tokens or Docker Hub tokens or JFrog tokens, and those can become potential for other attacks. And CodeCo was one such attack where state-sponsored actors were able to, let's say, change the code in the CI system, and they were able to, let's say, exfiltrate some of these secrets. As you can see in the last line there, they were able to curl a lot of these environment secrets to their own specific domain or their own specific server, and that's a very important attack vector that they used. So as I mentioned earlier, given these two important attack vectors to protect from supply chain attacks, the way to think about is very similar from what we've been doing for the last 20 years. So when it comes to production security or runtime security, I think the first thing that everyone did was put a firewall on top of it. And I think the same concept can be applied here on the CI system as well. So basically to protect against secret exfiltration, it totally makes sense to apply a firewall. But the interesting thing is that CI itself is just a traffic source. It's not a traffic sink. So I think just an egress filter is imperative. You don't really need anything else there. And my talk will be mostly about that, not about the other threat vector, which is the build tampering one. So I think even if we want to talk about egress filter for a build system or for a CI system, I think one of the things to probably see right now is given that the internet itself has become quite complex, a lot of the internet traffic today is behind CDNs like, any sort of CDN like Cloudflare. And a lot of people host like, their domains on like, services like Wix or something else. So the idea is that IP-based rules for an egress filter will probably not work. And I think even the firewalls have moved towards like, having a TLS-based systems. So, like even when we were thinking of building something for CI security, this is the approach that we also took, that we sort of built a very transparent egress filter. What that would do is create a whitelist of domains that a build system would require and only allow egress traffic to those domains. So, we built this tool called Bolt, which is open source, and we did it specifically just for GitHub Actions to demonstrate CI security. And this is an example run of Bolt. As you can see on the configuration on the left, there are some egress rules that we applied. For example, we wanted to, just for example, block Google. And as you can see on the right in the enforcement of Bolt, you can see that Google has been blocked in this is in enforcement mode. And there are some domains like github.com, ifconfig, github.com and others, which are allowed because these are some defaults that are required to run GitHub Actions. Now, the reality is, while we felt this was an interesting way to sort of, secure your CI, but is it enough? Because I think there are a lot of, open source things which are hosted on GitHub or Docker Hub, but even an attacker has, their own GitHub account. They'll have their own Docker Hub account or a JFrog account. So these CI systems are making API calls to, multi-tenant systems like GitHub, Docker Hub. So I think just having a domain level inspection will not work. You require some sort of deep SSL inspection to figure out where exactly this traffic is going, what is the kind of traffic that is outbound. And I think as we all know, eBPF is one such technology which has become panacea for all security ills. That's what we also used here. But the main purpose is to do deep SSL inspection on the outbound traffic so that you're able to see where exactly the traffic is going and what exactly is in that. I think obviously configuring eBPF and doing all of that is pretty complicated topic. I'll just give you a brief on how we did it, especially in the build systems, and some of that can actually be used for, let's say, other use cases even in runtime security or cloud security. I think the broad idea with eBPF is to actually capture network packets before encryption and after decryption, and you want to pass these packets for the SSL inspection. And then because our main purpose is to figure out which specific GitHub and Docker Hub accounts the traffic is going to, you want to create some root level rules to enforce controls across all of these tenants. And I think maybe I'll just get to this later. So we used Tracer, which is built by CubeShark on how to configure eBPF. Broadly, the idea is that there is Tracer has its dependency called Capstone, which is a disassembler for binaries. And what you want to do is you want to use Tracer to capture and modify PCAP files to understand HTTP request data and apply rules on top of that data to check for the tenancy. So a lot of this code is open source. You guys can go and have a look. And I think what I want to mention is that the main sort of instrumentation here happens across K-probes and U-probes. And you also want to add trace points to syscalls to actually be able to capture all of the traffic. Overall, what I would say is that eBPF implementation has some amount of complexity, but the complexity depends upon the TLS library of the code that is being written in the CI system. The reality is that TLS libraries are sort of limited, libSSL, boring SSL, and for Golang there is crypto-TLS. Now, the implementation of eBPF for libSSL and boring SSL is quite similar. Crypto-TLS has a little bit of a, the hooks are a little bit different. So I think maybe what I want to mention is that there the ureturn probes have sort of a declassifier that we need to use, and we've used Capstone for that purpose. So overall, the good part about using eBPF in such a situation is that the implementation sprawl is limited to just like two different kinds of implementations. The other thing is that eBPF also has a graceful failure in case like you set it up or like instrumented it incorrectly, and we use like a lot of open source tools itself to actually do that in Bolt. And if I just like go to a full Bolt run, you can see that there is some configuration we've done on the left where we have some trusted GitHub accounts where we want to allow traffic to, apart from like the normal egress rules. And on the right, you can see the results of Bolt we did on some example GitHub actions. And like some destinations we wanted to be blocked have been blocked. And not just that, we've also been able to figure out where like requests are going to if any sort of untrusted GitHub accounts. And this is something you can see, run Bolt and like see for yourself. So I would say, given we are able to use eBPF to do some sort of like deep SSL inspection, you can go even a step further and figure out like what exactly is in the traffic, not just like where the multi-tenant systems are and the sub-tenancies, but also understand what is the traffic that is going, and maybe like even figure out if there are some environment secrets which are being exfiltrated. So you, and also like if there are some specific sub actions which have excessive permissions. And as I mentioned, like eBPF has a lot of other use cases in like runtime security, whether checking like there is some PII data that is being leaked to like your cloud or production systems, or if you want to do some sort of container runtime security as well, or like even I would say a lot of these modern EDR and XDR systems are built on top of eBPF. So this is mostly from me. We have like the QR codes for Bolt, which is an open source project that you can use. And this is me, Abhimanyu from Koala Lab. In case you guys have any questions, I think we are sort of out of time, and I think I'm the last session before lunch, so I'll not take up more of your time. And in case you guys wanna catch me and wanna ask more about Bolt, I'm happy to be like give time during lunch. Thank you so much.